Each grower develops their own way of working: when to measure, what to check, when to turn on a pump, when to wait, when to act. This practical logic is the most valuable part of any automation. Until now, turning it into a working system required programming. Flows removes that barrier, letting anyone build their own automation without writing a single line of code. Flows is a visual editor for creating instructions the system executes. It's important to separate the editor from the flow itself. The editor is the tool for building logic. The flow is the instruction, a sequence of actions, conditions, and decisions. It doesn't run anything on its own. Execution belongs to the flow engine, which reads these instructions and carries them out step by step. Building a flow is like explaining a process to another person. Read the sensor, check the result. If the condition is met, go one way; if not, choose another. Turn on the device, wait, repeat until the condition is met. Each block represents one clear idea, and connecting blocks builds the full logic. The editor provides everything needed: sensor reads, actuator control, conditions, loops, weights, calculations, variables, logging, and flow control, combined freely with no limit on complexity. A flow can be a single, simple action or a long, structured sequence. The user decides the level of detail. A core architectural idea is separating logic from configuration through two types of variables. Local variables exist only during execution, temporary memory for values like a sensor reading. Global variables are external settings: tank level, max EC, watering time. Instead of being hard-coded, they're set by the user at runtime. This means the same flow can run across different programs, installations, or users without ever being edited. Only the parameters change. A flow can be exported and imported into another system. The user just assigns their own devices and sensors. What's shared isn't a configuration, it's a proven engineering solution built on real experience. Another distinctive feature: the intelligence lives inside the blocks, not in the connections between them. Take actuator control. A standard pump has no idea how much water it delivered. In CeresFlows, a witness sensor can be assigned to it. The system measures before starting, waits for the water to stabilize, measures again, and calculates the real amount added. A simple pump with no feedback of its own becomes an intelligent device. No extra hardware, no custom code. Every block also carries its own safety and error handling logic: retry attempts, whether to stop or continue on failure, and when to notify the user via telegram, on error only, on every run, or never. This lets each part of an automation be tuned to its own level of criticality. Flows is built to stay stable over time. A flow describes intent, not a specific implementation. As the flow engine evolves and gets smarter, existing flows keep working unchanged, protecting the time invested in building them. In the CeresFlows ecosystem, flows is where system behavior is created. Hardware provides data and executes commands. Other modules analyze, store, and visualize it. Flows decides when, why, and under what conditions each action happens, turning individual components into one coordinated, automated system. The most valuable automation never starts with code. It starts with human experience. Flows is the bridge that turns that experience into instructions the machine can understand, execute, and carry forward.